Alright, yeah, welcome back to Neco solution series on physics. So question number 1 says, a man placed a shaving mirror at a distance of 20 centimeters from his face. If the image of his face appears to be at a distance of 30 centimeters behind the mirror, calculate the radius of curvature of the mirror. So if you look at this question now, the question is some hidden facts inside the question. So they said a shaving mirror at a distance of 20 centimeters from his face. Remember, they said the image is formed at a distance of 30 centimeters behind the mirror. So what type of image that is formed behind the mirror? That is the first question you ask yourself. That is a virtual image. Then, what type of mirror do we use for a shaving mirror? That is what? Concave mirror. When you get these two questions right, then we are good to go. So we said any mirror that form image behind is a virtual image. The image is virtual. And for the fact that the mirror is a shaving mirror, that is concave mirror. Concave mirror. So if I've gotten these two facts right, then you are good to go. So let's quickly do something. So for a concave mirror, this is what we have. Now, this is the principal focus. This is the center of curvature. Now, in concave mirror, the only place where the image is virtual is when the object is between the principal focus and the pole of the mirror. So let's say the object, the man, for it to happen like that, the man must be between the principal focus of the mirror and the pole. So this is the man, right? So that is the object. So the distance between the mirror, the man and the mirror is said to be 20 centimeters, right? Now let's see how the image will be formed behind. So by illustrating the ray diagram. So this is the incident ray, then it will be reflected through the principal focus. Reflected through the principal focus. This is the reflected ray. Now the ray that passed through the center of curvature undeviated, so it passed through the center of curvature and also reflects through the center of curvature undeviated. So when you produce these two rays backward, so the point of intersection is where the image will be formed. So this is the image. Let's say the distance is said to be 30 centimeters. So this is just for illustration. This is not needed in the question. It's for better explanation. So we have the object distance u is equal to 20 centimeters and the image distance v. So the image distance is going to be minus 30 centimeters since the image is virtual, using positive is real sign convention. Positive is real sign convention. Right? So then focal length, we don't know. The question says we find the radius of curvature r. Remember the relationship between the focal length and radius of curvature. Recall that focal length f is equal to radius of curvature all over 2. So using mirror formula, that 1 over f is equal to 1 over u plus 1 over v. So you might decide to make f subject to the formula first. You might decide to make f subject to the formula. Doing that, I can find LCM here, uv, then uv divided by u will cancel u, will be left with v multiplied by 1 gives us v, plus uv divided by v will cancel v, will be left with u multiplied by 1, you have u. This implies 1 over f is equal to v plus u all over uv. So let's cross multiply, meaning that f multiplied by v plus u, f multiplied by v plus u is equal to 1 multiplied by uv, that is uv. Then for us to have f, we divide both sides by v plus u. V plus u. So then this one we cancel this, we left with f is equal to uv all over v plus u. Are we together? So now let's input the value. So f will be equal to u is 20 multiplied by v is minus 30 all over minus 30 plus u, which is 20. So that make our f equal to 20 multiplied by minus 30 gives us minus 600 all over minus 30 plus 20 gives us minus 30. So minus, we cancel minus, so 0 cancel 0. That implies f is equal to 60 centimeters. Having gotten the value of f, using the relationship we have that f is equal to r all over 2, which implies r is equal to 2f. So r will be equal to 2 multiplied by 60, which will give us 120 centimeters. So this is the answer. It shows that the radius of curvature of the mirror is 120 centimeters. I hope this is understood. Right? I told you there's no point of drawing the diagram. The first thing you should understand is that the question said the image is formed, virtual image is formed. Take note of that. The second is that the image, the second is that the mirror is a shaving mirror, and the only mirror we use for shaving is concave mirror, not convex mirror. So when you have identified these two facts, virtual image, concave mirror, then you'll be able to deduce that, okay, using the sign convention, positive is real. For a virtual image, the distance of the image is negative. and the distance of the object is positive, and the focal length of a concave mirror is also what? Positive. You can get that from the fact that at the end of our answer here, we have our focal length to be what? Positive what? 60 centimeter. Are we clear? So that is for question moving on to question number 8. Question 8 says a wire of length 4 meter has a resistance of 6 ohms if its radius is 0.45 millimeter. Calculate the conductivity of the wire given that the pi is 3.14. So question 8. Given that the length of the wire L is 4.0 meter and the resistance R is equal to 6.0 ohms. The radius is 0.445 millimeter. Since this is in meter, we have to convert to millimeter. Converting 0.45 millimeter to meter, remember you have 1 meter is equivalent to 1000 millimeter. So converting to meter will be R will be equal to 0.45 all over 1000. That will give us 4.55 minus 4 meter. So, and the question says we are given that pi is 3.14, and the question says we should calculate conductivity C. So we are looking for conductivity. Remember that there's a relationship between conductivity and resistivity. So resistivity is the reciprocal of conductivity, which implies conductivity is equal to 1 over resistivity. So for us to get resistivity before getting conductivity, you will recall that resistance of a conducting material is proportional, directly proportional to the length and inversely proportional to the cross-sectional area. So remove the constant of proportionality gives us R to be equal to rho L over A, and we call the constant of proportionality as the resistivity. So from here it implies that our resistivity is equal to RA all over L by making resistivity subject of the formula. So when you are done with this, so you remember in the question we are not given the area direct, but we are given the what? Radius. So you have to calculate the area. Know that area A is equal to pi R squared. So pi is 3.14 multiplied by the radius, which is 4.5 times 10 raised to power minus 4 all squared. So that will be 3.14 multiplied by 4.5 times 10 raised to minus 4 squared gives us 2.025 times 10 raised to power minus 7. So multiply them together, we'll have 6.3585 times 10 raised to power minus 7 meters squared. So we have gotten our area. So the next thing is to substitute the value into this formula. So we have rho is equal to RA all over L. So R is given to be 6 multiplied by A, which is 6.3585 times 10 raised to power minus 7 all over the length, which is 4.0. So multiply the numerator, gives us 3.8151 multiplied by 10 raised to power minus 6 all over 4.0. So divide the numerator and denominator, which gives us 9.5378 times 10 raised to power minus 7 ohms meter. So that is the unit of resistivity. Now, for us to get conductivity, we know that conductivity is equal to 1 over resistivity. So that will be 1 all over 9.5378 times 10 raised to power minus 7. When you do the reciprocal, we have it to be 1.048 times 10 raised to power minus 6 per ohms per meter. So that is the answer for question number 8. So resistivity and conductivity are related in this form. So that's all for now. Thank you for watching.